Okay, so we have problem number 4, 5, 6 and 7 from chapter 2 of Hall and Knight higher algebra. In all these problems, it is given that A is to B is equal to C is to D. And given that this is true, we have to prove 4, 5, 6 and 7. That is, we have to prove these relationships. Now, before we solve each of these problems, I want to introduce to you one rule called componendo and dividendo. Okay, componendo and dividendo, and I will show you how to use it. Now, the rule of componendo and dividendo says that suppose we have two ratios A by B and this is equal to C by D. Okay, suppose we have two ratios A by B is equal to C by D. Then the rule of componendo and dividendo says that PA plus or minus, that is, you can either add or subtract, whatever you want to do, Q times B is equal to, say, M times A plus minus N times B. Okay, P, Q, M and N are some arbitrary integers. Now what it says is whatever we have done on the left hand side, if we do the same operations on the right hand side, then we get equal ratios. Okay, so what it says is we have to, if we do same P times C plus minus Q times D, M times C plus minus N times D. So if this ratio were equal, then whatever operation we do on the left hand side with the numerator and denominator, if we do the same operations on the right hand side with the numerator and denominator, then we end up getting the same ratios. Okay, as an example, let us say that 2 by 5 is equal to 4 by 10. Okay, these ratios are equal. Now let us say M is equal to 4, N is equal to 1, P is equal to 2 and Q is equal to 3. I am just taking some arbitrary integer. Okay, now suppose we say P times 2. Okay, so this becomes 2 times 2. Suppose in the numerator we add plus Q times 3, so 3 times 5 divided by M times A, so 4 times 2. Now let us say we subtract minus 1 times B, so minus 1 times 5. Okay, one very important thing over here is that the denominator should not become 0, because otherwise if denominator becomes 0 we will end up having a division by 0 problem. So this is true as long as the denominator does not become 0. Now we do the same operation to this fraction, so it becomes 2 times 4 plus 3 times 10, okay, 3 times 10 divided by 4 times 4 minus 1 times 10. So here you get 4 plus 15 is equal to 19 by 8 minus 5 is equal to 3. Correct? Over here you will get 4 times 2 is 8 and then 3 times 10 is 30, so you get 38 by 16 minus 10 is equal to 6, and you can see that 19 by 3 is equal to 38 by 6. So this is what basically componendo and dividendo is. if you do the same operations on the right hand side as well as you do the same operation on the left hand side, then you end up getting the same ratio. Okay, so I hope you have understood the componendo and dividendo. Now let us try to solve the problem numbers 4, 5, 6 and 7. So first let us solve problem number 4. Now problem number 4 is, we are given that A is to B is equal to C is to D, and we have to prove that A square C plus AC square is to B square D plus BD square will be equal to A plus C cube is to B plus D cube. Okay, so we are given A is to B is equal to C is to D. Now let us say that this is equal to K. Okay, if you have gone through the problems of the first chapter, we know that K is also equal to, we add the numerators, so you get A plus C A plus C over B plus D, correct? Now what is the value of A times C times, what is the value of A over B times C over D times A plus C D plus D? What is the value of this expression? This is equal to K, this is equal to K, this is equal to K. So we get this is K cube, which can be written as, we know that K is equal to this, it can also be written as A plus C cube over B plus D cube. So we have already got the right hand side, okay, from here. Now what is AC times A plus C? AC times A plus C is A square C plus AC square. And what is BD times B plus D? It is B square D plus BD square. This is equal to K cube, this is equal to A plus C cube over B plus D cube. So we have proved the problem number 4. Now let us look at problem number 5. So for problem number 5, I think we have space here, so we can do problem number 5 here. Okay, problem number 5 we will do in green color. Again, we are given that, this is problem number 5, we are given that A by B is equal to C by D is equal to K. Okay, now we know that PA square by D and QB square, this will be equal to PC square by QD square right? All we are doing is we are squaring this, so this will be equal to P by Q K square. Okay, each of these expressions. Now P by Q K square will also be equal to P A square plus P As now we are doing the component and dividend, PA square plus QB square, then PA square by minus QB square. So what we said in component and dividend, that if we do whatever we do on the right hand side, if we do same things on the left hand side, we'll end up getting the same result, correct? So this should be equal to PC square plus QB square by PC square minus QB square, and we are done, right? So this is what we had to prove in the second problem. I mean the fifth problem. Now for the sixth problem, okay, now we'll do the sixth problem. Let us choose color blue. Problem number 6. Again we have been given that A by B is equal to C by D. Now we know that this should also be equal to A minus C by B minus D. Okay. Now we also know that this should be equal to A square let us say that each of these expression is equal to some constant k. Now let us say what will be the value of A square by B square. This will be equal to k square. This will also be equal to c square by d square. This will be also equal to a square plus c square by b square plus d square. So what will be the value of k? The value of k will be just the square root of this expression, which is a square plus c square by b square plus d square. Okay, so this is problem number 6, and for problem number 7, we have already proven that a square plus c square is to b square plus d square is equal to k. Okay, that is a is to b equal to c is to d. This is equal to a square plus c square by b square plus d square. All these ratios are equal to k. Okay, now what we can write is in this expression, that is a square plus c square, let us multiply this by c by a. Okay, let us multiply this by c by a. So we have to do the same thing in the denominator, that is we have to multiply b square plus d square also by c by a. Correct? We are just multiplying same c by a in the numerator and denominator. Now what we know is that if A is to B is equal to C is to D, then C is to A is equal to D is to B. That is, we have just brought down A from here and brought the D here. Okay, so what it means is, this implies that K is equal to, you multiply A square by C by A, you get AC, plus you get C cube by A, okay, divided by, now instead of C by A here we can replace it by D by B. Okay, so this one we can replace by D by D. So what is D square times D by B? It is DD plus D cube by B. So K is also equal to AC plus C cube by A is to BD plus D cube by D and the square root of this expression. So this is what we had to prove in the problem number 7, and we are done. I hope you have understood all the problems. If there is any doubt, you just leave me a comment and I will try my best to explain it